Welcome to this specialized training session on information systems auditing. Today, we are moving into the execution phase, specifically focusing on a critical competency for modern auditors, audit data analytics. We will move beyond basic sampling to understanding how to leverage technology to analyze entire populations of data. Let's get started. Let's contextualize where we are. You've planned your audit. Now you are executing it. Execution is about gathering data and evaluating controls. Traditionally, we might manually review a few records. But in the modern landscape, we use audit data analytics. Think of this not just as looking at data, but as using computational techniques to analyze massive data sets. Why is this critical? Because it allows us to evaluate the effectiveness of controls across the entire population of data, not just a small slice. This is the foundation of modern audit execution. Looking at the diagram, we see the flow from planning to execution. Within execution, data analytics acts as a central engine. Instead of a single output, it branches into three powerful advantages: achieving 100% coverage of transactions, generating deeper insights into operations, and significantly enhancing fraud detection capabilities. Why should you invest time in analytics? First, efficiency. It automates the grunt work. Second, and more importantly, accuracy. Traditional sampling has a sampling risk, the risk that the sample doesn't represent reality. Analytics can test every single transaction, effectively removing that risk. Third, fraud. Fraud often hides in the noise. Analytics highlights anomalies and patterns that are invisible to the naked eye. Finally, it enables continuous assurance, allowing us to monitor risks as they happen, not 6 months later. This comparison illustrates the shift. On the top, traditional audit relies on manual sampling, which inherently carries the risk of missing material errors. Below, data analytics processes the full population. This leads directly to high assurance, and through automated pattern matching, robust fraud detection. It's a fundamental upgrade in audit quality. So what tools do we use? We call them CAAT's computer-assisted audit techniques. The heavy lifter here is Generalized Audit Software, or GAS. This allows us to pull data directly from various systems without needing to be a database expert. We also use test data, where we feed the system bad data to see if it catches it. We might use scanning tools to look for vulnerabilities, or write custom scripts if we need to query something very specific. CAATs are your toolkit for execution. Visualize your toolkit. At the center is CAATs. Branching off, we have GAS for data extraction, test data for logic verification, utilities for scanning vulnerabilities, and custom scripts for tailored analysis. Each tool serves a distinct purpose in the audit execution phase. How do we actually run an analytics procedure? It's not just running a script. First, plan. What question are you answering? Next, acquire. Get the data, but ensure you have read-only access so you don't accidentally change live data. Then validate. Prove the data you got is the data that exists. Use control totals. Only then do you analyze, sort, filter, check for duplicates. Finally, report. Data doesn't speak for itself. You must interpret the anomalies. Follow the sequence. The auditor starts by defining the objective. We request data from the system strictly read-only. The system provides the extract. Crucially, the auditor validates integrity using hashes or totals before any analysis happens. Then we perform the analysis and investigate the specific exceptions found. Let's drill down into GAS. This is the auditor's Swiss Army knife. It allows you to perform complex math, stratify data, like grouping high-value transactions, and find duplicates instantly. The biggest win here is independence. You aren't relying on the IT admin to run a query for you. You access the data yourself, which makes your evidence much more reliable. It's versatile across different systems and is your go-to for substantive testing, like recalculating interest or verifying inventory. Here's the GAS workflow. We start with raw data from a database. We import it into the GAS tool. Inside the tool, we execute specific functions: stratification to group data, duplicate checks to find errors or fraud, statistical sampling for testing, and gap detection for missing sequence numbers. All these functions output robust audit evidence. Now we move to continuous auditing. First, audit hooks. These are triggers we embed in the system. If a transaction hits a certain criteria, like a massive cash withdrawal, the hook flags it immediately. It's an early warning system. Second, the Integrated Test Facility, or ITF. Imagine creating a fake department in your live company system. We run test transactions through this dummy department alongside real business. This lets us verify the system's logic is working correctly right now in the live environment without stopping the business. This diagram shows the live system processing. A transaction enters. First, it passes an audit hook. If criteria are met, it immediately alerts the auditor. Otherwise, it continues. Simultaneously, we see the ITF path. If the data is tagged as dummy data, it flows through the live system logic to verify correctness, ensuring the system works as designed. Two advanced continuous techniques are CIS and SCARF. CIS stands for Continuous and Intermittent Simulation. Here, the audit system simulates the transaction in parallel with the real system. If the simulator's result differs from the real result, we have a problem. SCARF, or Systems Control Audit Review File, is an embedded module that sits in the system and hoovers up specific high-risk transactions into a special file for the auditor to review later. These are complex, high-maintenance tools, but they provide incredibly high assurance. Let's trace the CIS logic. A transaction input enters. It goes to the live application and the CIS simulator simultaneously. The live app produces an actual result. The simulator produces a simulated result. We then compare them. If they match, the system passes. If there is a mismatch, an exception report is generated immediately. We conclude with challenges. Great power brings great risk. First, data integrity. You must prove the data you analyzed is the data that was on the server. Second, access. You must strictly use read-only access. Changing production data is a fireable offense. Third, security. You just extracted the company's most sensitive data onto your laptop. It must be encrypted and secured. Finally, independence. If you rely on a script written by the IT guy you are auditing, you aren't independent. Verify your tools. This visualizes the risks and controls. The central process is audit data analytics. We face risks like tampering, accidental change, and data leaks. We mitigate these directly. Hash totals prevent tampering, read-only access prevents accidental changes, and encryption prevents data leaks. These controls are non-negotiable.